All right, friends, here's your homework checker for Thursday, October 26th. Computation Square says, what problems could be equal to 2,400 or 2,400? So I'm having to solve all of these problems to figure out which one's equal 2,400. So let's show our work. A says 60 times 40. So let's solve this. If I cover up the 0, 6 times 4 is 24. If I multiply the 10 back to it, add the 0 on the end, I get 240. It's not what I'm looking for. I'm looking for 2,400. That's our magic number. Let's check B. Cover up my zeros. 6 times 4. Well, I just did that for A. I know that's 24. I have 2 zeros here that I have to put back on my number. 2,400. That's what I'm looking for. Yeah, so B is a possible answer. Let's check C. 300 times 8. 8 times 3 is 24. I have 2 zeros here, so I'm going to put 2 zeros back. Another 2,400 or 2,400. Yeah. Let's check our last one, D. Let's cover up our zeros. 24 times 1 is 24. I have 2 zeros here, so I put my 2 zeros back on there. Look at that! Another answer choice that equals 2,400. 2,400. There you go. If you showed all your work, you know there's more than one answer. Next one asked you to find the greatest common factor of 14 and 21. Keyword, factor. Factor means we make a factor rainbow or our factor trees. Let's do it. Factors of 14. Start off with the easiest ones, 1 and 14. It's even, so 2 is going to go into it. 2 times 7. Nothing times 3. Nothing times 4 equals 14. Nothing times 5. Nothing times 6. Something times 7. But we're done. Let's check 21. 1 and 21. There's nothing times 2 that equals 21. There is something times 3. 3 times 7. Nothing times 4. Nothing times 5. Nothing times 6. There is something times 7. So we know we're done. Let's circle what they both have in common. They both have 1s and they both have those 7s. So the GCF of 14 and 21 is 7. Make sure you show your work. Put the GCF for that square. Okay, next square is asking me to round 392,368 to the nearest hundredths place. It has a number line here in case you learned how to round on a number line, which Miss Ryan definitely taught. So, here's a little refresher in case you need it. Here's my number. I underline the place value I'm rounding to. So when I'm rounding it on a number line, I'm seeing what two numbers is it in between. So it's in between 392,300, 392,400. And our midpoint would be 392,350. Did you already know that? I'm sure you did because you're brilliant. So let's see, where would this number fall on our number line and which side is it going to round to? So 392,368. I'm just going to really focus on that 368 here and say, okay, it's greater than the 300 here. It's greater than the 350 here. So it's going to stick right about there on our number line. And I know that 6 tells me 5 or more raise the score, so that 3 is going to bump up, and that's going to estimate to 392,400. So that's what that looks like for the first number line. The next part of this question says round 392,368 to the nearest 10,000. So it's the same number, it's just asking me to round to a different place value. So my number line is going to look different. So here's my work for this. I underline my 10,000ths place. The digit in the 10,000ths place is a 9. So when I'm labeling my sides of my number line, this is going to be 390,000 and I'm going to add 10,000 to it, which is going to be 400,000. My midpoint will be 390, what do you think? 95,000. Yeah, that midpoint usually always has a 5 somewhere in it. So when I look at my number, I'm going to just focus on this 392 and figure out where would that number go on this number line. Is it greater than 390? Well, yeah, it is. 392 is greater than that. Let's go to our midpoint. Is it greater than 395,000? No, it's not. It's actually going to stick right here on our number line. So when we look behind it, 392, 4 or less, let it rest. This is why we let it rest, because it is closer to 390,000 than it is to 400,000. Okay, next square says, what is 10,000 less than 6,347,629? So 10,000 less. That means I'm going to take away 10,000 to this number. So if I go to my 10,000s place, that's 4, I'm going to subtract 10,000 from it. Now in my head, I'm just going to look at this and take away that number, because if you notice, all the other numbers are really going to stay the same except for my 10,000s place. So 9 minus 0 is 9, 2 minus 0 is 2, 6 minus 0 is 6. 7 minus 0 is 7, 4 minus 1 is 3, 3 minus 0 is 3, 6 minus 0 is 6. So if I take away 10,000 from that number, I get 6,337,629. So if you look at that number, this is really the only place value that changes. Let's look at our next question. It says, what is 1 million more than 375,652. So here we have the keyword more, which tells me in this case I'm adding 1,000,000 to this number. So if I look at this number, literally the only place value that's going to change is the millions. Well, this one doesn't have any digits in the millions. So I'm literally just adding 1,000,000 to this number. Everything drops down and stays the same, and I'm going to add 1,000,000 to it. So it's 1,375,652. That's going to look like some of y'all's paychecks one day. Oh yeah, all because of your 4th grade teacher. That's right. Okay, in your word problem, we have the Saints scored 5 touchdowns. If each touchdown and extra point were 7 points, how many points did the Saints have total? Oof, I love this word problem. Plus, it's a real-life word problem. And you know my Saints are scoring mad touchdowns. All right, let's show our work using the UPSC. So for my understand, I got to put all the numbers that I need to know. 1 is 5 touchdowns. The next one is how much those touchdowns are worth, which are 7 points, if they make the field goal. The question is, how many points is that total? How many points would they have on the scoreboard if they scored 5 touchdowns? So, my plan is to multiply touchdowns times points, which is going to be 5 and 7. So let's solve it. 5 times 7. Oh, that should be a quick fact for us. We can skip count by 5. 5, 10, 15, 20, 25, 30, 35. 35 points for my awesome Saints. Oh, yeah. To check it, we could kind of do a lot of different things. We could do the commutative property of showing that 5 times 7 equals 7 times 5. You could draw out, 5 with 7 in each of it. Okay. Little footballs there maybe. Yeah. Make it all relate. So that's a way to solve that problem. All right, friends. Go Saints!